Hi, and welcome to this video about the volume and surface area of a cube. We see this shape everywhere, most commonly with blocks and dice. And then there's the colorful puzzle known as a Rubik's Cube, which is a cube that appears to be made up of smaller cubes. In math, a cube is a special kind of rectangular prism. In most rectangular prisms, the length, width, and height of the shape can all be different, but in a cube, they're all the same. That is to say that the edges are all the same length. There are two important measures of a cube. The first one is the volume. The volume of a cube or any other 3D object is a measure of how much space it takes up. We measure this in cubic units, such as cubic inches or cubic centimeters. It's easy to picture this with a cube. Just imagine that we have a bunch of little cubes that are 1 centimeter tall, 1 centimeter wide, and 1 centimeter long. Each one of these cubes is 1 cubic centimeter. This is our unit of measure. Now let's build something from these little cubes. Let's build something that looks a lot like a Rubik's Cube. We'll start with the top level. We need to make a 3x3 grid of the cubes. Each cube is 1 centimeter tall and 1 centimeter wide. Once we're done with that layer, we can see that we've used 9 cubes, which makes 9 cubic centimeters. Next, we build the middle level using another 9 cubes. Altogether, 9 and 9 makes 18 cubic centimeters. Finally, we build the bottom level, again using 9 more cubes. Altogether, we've got 27 cubic centimeters. Our finished shape is a cube made up of smaller cubes. How many did we use? 9 on each layer for a total of 27. We used 27 1 centimeter cubes, or cubic centimeters, to make our bigger cube. Fortunately, to find the volume of every cube, we don't need to build one out of smaller cubes. There is a formula we can use instead. The formula for the volume of a cube is V equals A cubed. V is the volume and A is the length of an edge. Remember that all the edges have the same length. If we measure the area of this cube, we find that all the edges are 3 centimeters long. So to find the volume, we can substitute 3 for A in our formula. We raise it to the third power, which is 3 times 3 times 3, which gets us 27 cubic centimeters, which makes sense since we needed to use 27 of the little cubes to build our cube. Remember that it's very important to specify the units when giving our answer. The other main measure of a cube is surface area. It's an area measurement, so it's in 2 dimensions. Imagine we were making a paper case for the cube we built earlier. How much paper would we need in square centimeters? If we look at the cube we built earlier and just look at one side of it, we can see a bunch of these 1 centimeter squares. If we count them, we can see there are 9, in fact. So one side is made of 9 square centimeters. But to find the surface area of the cube, we need the area of all the sides, not just one. Fortunately, since a cube is the same length, width, and height, that means that all the sides have the same area, and there are 6 sides. So we can multiply 6 sides by the area of one side, in this case, 9 centimeters squared, to find a total surface area of. That's how much paper we'd need to make our paper case. You may have seen a map like this. Just like with volume, we have a formula so we don't have to build a cube each time we need to find the surface area. The formula is surface area equals 6a squared. The 6 represents the number of sides of the cube, and the a squared is the area for each side. We can confirm that this works by plugging in our edge length like this. and then evaluating the expression. We need to remember to use the order of operations and apply the exponent before we multiply. If we do so, we see that we correctly figure out the surface area of 54 square centimeters for our cube. Thanks for watching and happy studying.